All right, today we're going to see if we can practice doing or showing you how to work through a word problem that has lots of different parts to it. So right now I see that it says gasoline has a density of 0.73 grams per centimeter cubed. Wants to know how many liters of gasoline would be required to increase the mass of a car from 1,271 kilograms to 1,205 kilograms. It also tells me the conversion between liters and cubic centimeters. But my goal is to increase the mass. Okay, so that's a number, those are numbers I'm going to need, but I'm going to have to subtract them to make them useful to me. So, that gives me a 4, 3, that's a 0. So 34 kilograms. I notice, though, that my density is not in kilograms. So if I want to save myself a step, I could write down that this is 30. Nope. Yeah, it was 34,000 grams. So that's how much I need to increase the mass by. Overall, I want to know this as a volume though. So somehow in my answer, volume with liters, that how many liters thing needs to be in my answer. So there's a couple ways you can approach this, and I'll do this problem in 2 different ways. 1 liter, so I know right here 1 liter, and it wants to know how many liters. So I can start with that. 1 liter is 1,000 cubic centimeters. Well, I know then that 1 centimeter cubed is also 0.73 grams of gasoline. Liters I still have. Need to get rid of my grams. Well, I wanted to know 34,000 grams, that's how much you would increase the mass of the car. And that gets rid of grams, and then you notice that the only thing left is liters. And so you can cancel out some zeros, because I have 3 zeros here, 3 zeros here. So really my answer is whatever 34 divided by 0.73 is. That's one way to approach it, with the answer being listed first. Okay, we can erase all this and do the same problem in another way, if it makes more sense to you. Okay, some people will want to start with the mass because that's what we found. But that's not equal to anything, so don't put a number in the denominator. That's just how much the mass of the car is going to increase. So don't put anything in the denominator there. That sometimes throws students. Now, grams is in the numerator. That means whatever I find next needs to have grams here. Well, the only number with that is density. And I want to put centimeters cubed on the bottom, liters on the top. The 1,000 goes with the centimeters cubed. And so you'll see we have the same numbers kind of in the same place, like 34,000 still in the numerator, but they're in a different order. So that's a different way to do this. And you can still do, drop the zeros, centimeters cubed is gone, grams is gone, and you still end up with the same problem, but some people like the way of that approach. You can even start with the density. Some people will do that. Now, if you choose to start with density, you do need to think this through. Density is a fraction, but the type of unit you want is volume. That means you need to put 1 centimeter cubed in the numerator because liters and centimeters cubed are both volume measurements, and that has to be your answer. You can choose to go either way. I can choose to cancel grams. I can choose to cancel centimeters cubed and get it to liters. Right now, if I were to stop and do the math, I would have liters per gram, and I don't want liters per gram. And again, we have the same numbers, different order, but we still get the same result. That is one thing that some kids like about unit cancellation and some do not, is because they're like, oh, there's too many ways to do it. It should be. Just got to think your way through it, figure out what makes sense to you in terms of units. Some kids like to start with the answer first, then go ahead. That is not a problem. On the next one, it says a liquid has a density of 1.17 grams per centimeter cubed. How many liters of the liquid would have a mass of 3.78 kilograms? So we've got two different metric units going on here. We do want to know liters. That means our answer has to be in a volume. So however we decide to start this, volume needs to somehow start in the top so it will end in the top. So for this one, I'm going to start with the density, but I'm going to flip it and put 1 centimeter cubed over 1.17 grams. And I'm going to convert kilograms to grams in my head, so 3 decimal place move. There is nothing that goes in the denominator here, because this is not equal to anything. Now, from the previous problem, we know that if we have 1,000 centimeters cubed, that is the same thing as 1 liter. And centimeters cubed, grams, and grams, and that would give you an answer in liters. So you would take 3,750 divided by 1,170. I took 1.17 times 1,000 in my head. You can knock off a 0. Save yourself a number punch on your calculator.